What's up guys, this is Masi. Welcome to another video. In this video I want to solve some examples regarding kinematics, which are related to position, displacement, and average velocity. The first question is saying that while driving a car at 80 kilometers per hour, how far do you move while your eyes shut for half a second during a hard sneeze? So the first thing you need to do here, the velocity is in terms of kilometers per hour. And here we have the time in terms of seconds. So it means that it's better to convert this velocity from kilometers per hour to meters per second. So it's going to be 80 kilometers per hour. Then you can do some conversions. You can say 1 kilometer contains 1,000 meters, and 1 hour has 3,600 seconds. 60 times 60, because 1 hour is 60 minutes and each minute is 60 seconds. So therefore we can say we have 80 times 1,000 divided by 3,600, which will be 22.22 meters per second. And then we need to say how far do you move while your eyes shut for half a second. So we know velocity is distance divided by time, so it means that d equals to v times t. So d is going to be 22.22 meters per second time 0.5 seconds. So it's going to be 22.22 times 0.5. That's going to be 11.1 meters. So the final answer is 11.1 meters. In next question, I want to compute your average velocity in the following two cases. Case A, you walk 61 minutes at the speed of 1.2 meters per second and then run 75 meters at a speed of 2.9 meters per second along a straight track. So let's do A first. We know velocity equals to distance divided by time. It means that time is equal to distance over velocity. So in part A we have the distances and we have the velocity. So V average is going to be the total distance 61 meters plus 75 meters divided by time, which is going to be 61 divided by 1.2 plus 75 divided by 2.9. So 61 is going to be 136. 61 divided by 1.2 is 50.83. 75 divided by 2.9 is going to be 25.86. 136 divided by, it's going to be 76.69. So therefore it's going to be 136 divided by 76.69, which will be 1.77 meters per second. Now let's do the part B. In part B it says you walk for 1 minute at the speed of 1.2 meters per second and then you run for 1 minute at 2.9 meters per second along a straight track. So V average again is going to be total distance, which we don't know, but we have the velocity and time. So velocity times time is going to be the distance. So I'm going to say 1.2 meters per second times 60 seconds plus 2.9 meters per second times 60 seconds divided by total time, which is 2 minutes or under 20 seconds. So 1.2 times 60 plus 2.9 times 60 divided by 120 is going to be 2.05 meters per second. So the velocity of the second case is going to be 2.05 meters per second. This question, I want to solve an automobile travels on a straight road for 40 kilometers at 30 kilometers per hour. It then continues in the same direction for another 40 kilometers at 60 kilometers per hour. What is the average velocity of the car during the full 80 kilometers trip? And in the second part it says what is the average speed. So the first thing I'm gonna say here, it consists of two parts, and we have the displacement of the first part and displacement of the second part. Let's say we have delta x1 for the first part's displacement and delta x2 for the second part displacement, and the time for each part is going to be delta t1 and delta t2. That's the corresponding time intervals. So we can say velocity, average velocity, is going to be delta x over delta t. Delta x is going to be, since it's on the same direction, it's going to be delta x1 plus delta x2 divided by delta t1 plus delta t2. So then we can say that we have delta x1 and delta x2, but we don't have delta t1 and delta t2. Let's find out those first. Delta t1 is going to be distance divided by velocity, which is 40 kilometers per 30 kilometers per hour, and delta t2 is going to be 40 kilometers per 60 kilometers per hour. That's going to be 1.33 hour, and this one is going to be 0.67 hours. So delta t in total is going to be 1.33 plus 0.67 hours, so it's going to be 2 hours in total. So the average velocity is going to be delta x divided by delta t. So the total displacement is going to be 80 kilometers divided by hour is going to be 2 hours. So it's going to be 40 kilometers per hour. So that's the answer to part A. Let's do the part B. So this one was part A and this one is part B. It says find out the average speed. So in this case we can say that the average speed is the same as average velocity. Why? Because they are in the same direction. So in these two parts we have the same direction, so the magnitude of these two is going to be the same. So it's going to say S average is going to be the same thing, which is 40 kilometers per hour. In this example, we have a car moves uphill at 40 kilometers per hour and then back downhill at 60 kilometers per hour. What is the average speed for the round trip? So as you see here, we are talking about speed. We are not talking about the velocity. Why? Because average speed, unlike average velocity, relates to the total distance and not net displacement. Net displacement is related to the velocity, but the total distance is going to be related to the speed. So since it contains two parts, we can say speed is going to be delta x1 plus delta x2, which are the same thing because it's the same path, divided by t1 or delta t1 plus delta t2. So as you see here, we don't have delta x1 and we don't have delta x2. We don't have delta t1 and we don't have delta t2. But we know delta x1 equals to delta x2. Let's call it delta x. And in here we have delta t1, which is going to be equal to delta x divided by v1. Delta t2 is going to be delta x divided by v2, which is going to be delta x divided by 40, and here is going to be delta x divided by 60. So we have 2 delta x because we're adding. And here we have delta x over 40 plus delta x over 60. We do common denominator for solving this. You can say 120 times 3. Here we have 3 delta x plus 2 delta x. That's going to be 2 delta x over 5 delta x over 120. That's going to be 120 times 2 delta x divided by 5 delta x. Now delta x and delta x cancel out. We have 240 divided by 5. It's going to give us 48 kilometers per hour. So that's the average speed. If it said find out the average velocity, in that case, since the distance for the two sides is going to be the same, the total displacement is going to be 0, so the average velocity is going to be 0 then. This question is saying that the position of an object moving along an x-axis is given by this equation, which is x equals to 3t minus 4t squared plus t cubed, where x is in meters and t in seconds. Find the position of the object at the following values of t at 1 second, b at 2 seconds, c at 3 seconds, and d at 4 seconds. Part E is saying that what is the object's displacement between t equals to 0 to t equals to 4. And F is saying that what is its average velocity for the time interval t equals to 2 to t equals to 4. So let's start with the part A. For finding the position, we just need to put this 1 in the equation. So it's going to be x equals to 3 times 1 minus 4 times 1 squared plus 1 to the power of 3, which is going to be 3 minus 4 plus 1. That's going to be 0. Part B, we do the same thing. We sub 2 in here. 3 times 2 minus 4 times 2 squared plus 2 times to the power of 3 is going to be 6 minus 16 plus 8. It's going to be negative 2 meters. C, at 3 seconds. So x equals to 3 times 3 minus 4 times 3 squared plus 3 to the power of 3, which is going to be 9 minus 36 plus 27. That's going to be, again, 0 meters. Part D. It's going to be 4, 3 times 4 minus 4 times 4 squared plus 4 to the power of 3. These two cancel out, so it's going to be just 12 meters. Part E is saying that what is the displacement between time equals to 0 to time equals to 4. So it is going to be delta x equals to x at time equals to 4 seconds minus x at time equals to 0. So it's going to be 12 minus 0 is going to be 12 meters. F. It's going to be what is the average velocity for the time interval t equals to 2 to t equals to 4. So we have the average velocity equals to delta x divided by delta t between t equals to 2 and t equals to 4, which is going to be negative 2, and here we have 12. So it's going to be 12 minus negative 2 divided by 4 minus 2. That's going to be 14 divided by 2. It's going to be 7 meter per second. So that's the average velocity for the time interval of t equals to 2 to 4 seconds.